Welcome to the video for C2.2.5. So we're going to look at simple molecules of covalent bonding today. So before we start, I want you to pause the video when I finish speaking, and I want you to write the chemical formula for these molecules. So water, methane, oxygen, ammonia, carbon dioxide. So water and carbon dioxide you should definitely be able to do, and the others you might be able to do. So have a go at the ones you can. Okay, so hopefully we've had a go at these. So water, I expect most of us have managed to successfully write H2O, so that means I've got 2 hydrogens and 1 oxygen. Methane is CH4, so that's 1 carbon and 4 hydrogens. Oxygen, we know the chemical symbol is O, but it's actually a molecule, it's O2. Ammonia we might not have met before, but it's NH3, so it's 1 nitrogen and 3 hydrogens, and carbon dioxide is CO2. We've met that before. Okay, so our learning objectives for today, we need to be able to state that simple molecules can form when 2 non-metals react together. You need to be able to draw dot and cross diagrams for simple molecules, just like we could for ionic, and you need to be able to explain why simple molecules have got low melting points. So, non-metals, as we've already talked about when we did ionic bonding, need to gain electrons to have a full outer shell. So metals and non-metals can bond together because the metal atoms give their electrons to the non-metal atoms, and they both become ions in ionic bonding. Now, today we're going to look at what happens if 2 non-metals bond together. So because non-metals both want to gain electrons, in order to bond together they need to share electrons, and this makes simple molecules. So you can also have giant covalent molecules, but we're going to look at this next lesson. So today we're just going to concentrate on simple small molecules. And these have very weak forces between the molecules. So the intermolecular forces, the forces between the molecules, are weak. And because of that, their melting points are low. And because their melting points are low, most of them are liquids and gases. So there's the odd exception, but most are liquids and gases. So covalent bonding, we need to be able to draw dot and cross diagrams. So we're going to start with chlorine, which is Cl2. So the first thing we're going to do is draw the atoms with their outer shell. So chlorine is in group 7. So let me make sure I've got my pen. So chlorine's in group 7. So if I draw chlorine, so we're just going to draw the outer electrons for this. So I'm going to draw, because it's in group 7, it's got 7 electrons in its outer shell. Okay, so there's the first one. And then the second one. So I'm going to draw, just like we did right ionic, I'm going to draw dots for one and crosses for the other. So 1, 2, 3, 4, 5, 6, 7. So we can see here that there is a space there for an electron to go. It's only got 7 in its outer shell, it needs 8, and there's a space there. So what we can do is we can join those two together. So both chlorine atoms need to gain 1 electron, and they can do this by sharing electrons. So we put the atoms together and we keep moving electrons into the shared area until both atoms have got a full outer shell. Now I can't remember where my gap is on here, so this might go horribly wrong. So there's my first chlorine. So we're going to overlap those 2 circles just like we're drawing a Venn diagram. And then we need to place the shared electrons in the middle. So I'm going to take that single one there, I'm going to put there, and then the rest I'm going to put on the outside here. Excuse my bad drawing as usual. So now, so that's 1, 2, 3, 4, 5, 6, 7 electrons from there, and then I'm going to draw my cross there. 1, 2, 3, 4, 5, 6, 7. Okay, so now so it's important to draw these ones that are shared in that overlap of the kind of Venn diagram, overlap of the 2 circles. So if I now count for this chlorine here, I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons, so that chlorine's happy. And if I count for this one, that's 1, 2, 3, 4, 5, 6, 7, 8 electrons for that. So that one's happy. So now both of them have got 8 electrons in their outer shell. So they're both happy. Now I can draw a diagram, so with the 2 chlorine atoms, and that shared pair of electrons I can represent with a line. So that line there represents a covalent bond. Because sometimes we don't want to draw the whole diagram out. Okay, so they've now both got a full outer shell and they're more stable. So chlorine, if you find it as an element, is always Cl2, because as an individual atom, it's not stable, because it's only got 7 electrons in its outer shell. If I was to write the molecular formula for that, I'd write Cl2. Okay, and as I've just said, I can write the displayed formula, which shows the covalent bonds as sticks. Okay, so we're going to do another example here where we've got a double bond. So this is a bit harder. So I'm going to draw oxygen. So if you look in the periodic table, oxygen's in group 6. So I'm going to draw one oxygen there with 1, 2, 3, 4, 5, 6. And I'm going to draw one there with 1, 2, 3, 4, 5, 6. So now you can see that's only got 6 electrons in its outer shell, and it needs 8. So it needs to gain 2. So however many electrons it needs to gain, that's how many it needs to donate to the covalent bond. So if I put the atoms together, so let's do my overlapping circles again. So I need to put, because it needs to gain 2 electrons, I need to put 2 electrons in the overlap there. So there's my 6 from that one. And then from this one, it needs to gain 2 as well. So I need to put 1, 2 of the shared ones in. And then 3, 4, 5, 6. So if I now count these up, I've got 1, 2, 3, 4, 5, 6, 7, 8. And I've got 1, 2, 3, 4, 5, 6, 7, 8. So both those are happy. And I can write this now, because that's got two pairs of shared electrons. If I was to draw this out, I have to draw 2 lines because I've got a double covalent bond. Now it's not very well drawn that, but it's basically you draw like an equal sign. So that's a double bond. So there's a better representation of it. So you can see you've got 2 lines between the 2 oxygens. That's a double covalent bond. So when we're drawing these, we need to draw the atoms with their outer shell, remembering that the group number tells us how many they've got. And then you need to, however many electrons they need to share, needs to be, however many electrons they need to gain is how many electrons they need to share. So here's 5 for you to have a go at. Now I'm going to do the first one for you because we haven't done one where you need more than one. So if I do, so we're going to draw the atoms with their outer shell. So here's oxygen, 1, 2, 3, 4, 5, 6. Now I've drawn those in a specific place because I know where we're going to do, but it doesn't really matter. And then my hydrogen is here. So hydrogen's got 1 electron. And I'm going to draw another hydrogen over there, which has also got 1 electron. So hydrogen needs to gain 1 because there's only 2 electrons in that first shell. So each of those hydrogens needs to share 1. And that oxygen has got 6, it needs 8. So each oxygen needs to share 2. So what we're going to do is put those together. So that's going to become, so my oxygen's in the middle there, 1, 2, 3, 4. I'm going to overlap with 1 hydrogen there and another one there. So there's my original electron from the oxygen. There's my electron from the hydrogen. So that's my hydrogen, my oxygen, and my hydrogen. And that hydrogen now has 2. So 1, 2. The oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And that hydrogen has 1, 2. So they're all happy. And they've all got full outer shells. So I've drawn the atoms with an outer shell, I've put the electrons on the shells, I've then kept moving the electrons into the shared area until I've got a full outer shell, and then I've drawn the molecule in your book. Sorry, on my slide, so you're going to draw in your book. So I want you to do that for 2, 3, 4, and 5, and then the answers are on the next slide. So pause the video and have a go at those. Okay, so water is the one that we've just done on there. So that's a pretty example of what I've done. The methane ends up as that. So you've got the carbon in the middle and you've got 4 hydrogens around it. Ammonia ends up like that, and then nitrogen and carbon dioxide. Okay, so now you're done. Make any corrections to any work that you've done wrong. Thank you for listening. See you next time.